Jacob's hat. I guess it matches some of the threads in his shirt. That's fine. Okay, it's good. Yep, good call. Greetings and welcome, friends. My hat matchery-unies. We're on page 682. We were talking about, the book had a crazy title for this. I just call it Solving Systems of Conics. Taking a gander at this here, this first equation is in general form. Almost, actually. It's equal to 25 there. So this is a, what type of conic is the first equation? It's an ellipse because there are two squared terms and their signs are the same, but their nombres are different. And the second equation is actually a line. So I'm expecting as many as none, one, or two intersections between the following. So what I'm going to do in this case is, it looks like substitution wouldn't be a bad bet, because there's, I could solve this for like y, and then substitute in for y once I'm done. That seems to make sense. So let's subtract 2x from both sides. So I shall get y equals negative 2x minus 1 as my revised equation. And let's substitute that in for y. I'm expecting to get actually possibly a couple answers from this, unless it's imaginary or something. 4x squared plus negative 2x minus 1 all squared equals 25. So, going from here, now notice the benefit of this is that it's given me an equation all in terms of x. I'm going to have to remember this pattern, I believe, however. So that's a sad looking plus sign, plus b squared. And so I'm going to plug this in for a and this in for b. Bless you, friend.
You made a little mess.
So, friendly friends, keep tracking here. And then plus b squared, so that's 1 squared equals 25. This one, due to the two types of negatives there, I'm actually going to end up getting a plus sign here as a result, which is fine. So this is 4x squared plus 4x squared. Oh, that would have been wonderful if they canceled out, but they don't. Plus 4x plus 1 equals 25. So it looks like this is going to be a quadratic equation. So I'm going to group my like terms and then set it equal to 0. So I guess I could simultaneously subtract 25 from both sides. And I'll have 8x squared plus 4x minus 24 equals 0, if I'm not mistaken. And now if I could factor to solve this quadratic, complete the square to solve the quadratic, quadratic formula to solve the quadratic, all of that would be great. However, one thing that would be nice, I think I can actually make all of these numbers smaller. Just divide everybody by 4, because I hate to do math with bigger numbers than I need to do, so there we go. Minus 6 equals 0. Actually, I think that is factorable by the looks of it. Yeah, that's definitely factorable. Maybe, should we factor for fun? It's been a while since we've done an AC method.
I don't like factoring those, so
I think maybe we just do quadratic formula.
Okay, we'll just roll with quad today.
because then we'll get it.
So a equals 2. Yeah, that's a good call. Good call. Yeah, we'll just use the thing that'll work every time and save you the hassle. So x equals the opposite of b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. Plug it in and chug it. Plug and chug. Negative 1 plus or minus the square root of 1 plus 4 times 2 is 8 times 6, 48. Oh, no, they didn't. That's going to be done there, a perfect square. X equals negative 1 plus or minus the square root of 49, 7 fourths. Sorry, I scrolled a little farther than perhaps you guys were ready. So break this up into two cases. X equals negative 1 plus 7 is 6 fourths. So that's equal to 3 halves, which is equal to like 1.5. Or x equals negative 1 minus 7, which is negative 8 fourths, which is negative dose. So right there. So those are my two possible x values. I'm now going to plug them both into one of the other equations and solve for y. Actually, I think I probably have a real nice revised equation to work with. Let's see. I'll scroll back down in a second. Man. Let's see. Y equals negative 2x minus 1. Yeah. If I plug those in there, I can find their corresponding y values. Negative 2x minus 1. So I'll have y equals negative 2 times 3 halves minus 1, and y equals negative 2 times negative 2 minus 1. I get y equals negative 3 minus 1, or negative 4. Or over here, I get y equals positive 4 minus 1, or y equals 3. I guess I'll just box the numbers since that's what I've been doing. So that means the solutions are, I'll just write it decimally, 1.5 comma negative 4 and negative 2 comma 3 are the solutions to this. So two solutions. The intersection between an ellipse and a line is what we've got going there. Let's see. It says check the solutions by graphing each system. Oh man, you're giving me a challenge today, are you? I see what you got going there. Let's see if I'm going to open up some Geometria Sketchpad here just to get a nice, yeah. Let's see, new sketch, graph, grid form, rectangular. Yeah, so we're still recording this, so just hang out for a second. So Hank, you done writing?
Yeah.
Nice, thank you. I've got this grid coming at us in just a second. Now, based on the equations, let's see, 1.5 negative 4, 2 comma 3. I'm just gonna give myself plenty of grid space here and assume it'll be sufficient for me. Now, based on the equations, let me grab a snapshot of those equations again, perhaps. It's going to have a little arrow in there, but that's fine. To graph this, the ellipse equation, I would divide everybody by 4. I'd have x squared over 1 plus y squared over 4 equals 25. Oh, wait. Oh, guys, that's a crazy ellipse to have to graph. I have to divide by 25, not 4.
I don't know.
Well, let's see. The y one's a little bit easier to see. That'd be y squared over 25 equals 1. But check this out. This is 4/25 for this. But if I want to represent this completely in the denominator, I'd actually have to write that as 25/4 all in the denominator. I kind of have to reciprocate that. So that's a little crazy. But let's graph this real quick. I'll help you out. Center's at 0, 0. Let's see. Let's do the classic purple here. So center's at 0, 0. Which of these denominators is larger? 25 is bigger than 4 parts of 25. So it is vertically oriented. So I'd go up 4, down 4, and 25. Oh wait, the square root of 20. Wait a minute. Wait. Where did I get 4, guys? Square root of 25 is 5. So up 5 and down 5. My bad. And the square root of 25/4 is 5 halves, or 2.5. So I'd go over 2.5 and this way 2.5. And draw this nice handy-dandy ellipse going there. Ellipse, something to that effect. Now the other equation is a line. I solved it for y earlier, and I had y equals negative 2x minus 1. So for this one, the slope is negative 2. The y-intercept is negative 1, not positive 1, and negative 1. So to graph that, that would be y-intercept at negative 1. Slope of negative 2, so down 2 over 1, down 2 over 1, down 2 over 1. Or similarly, up to left 1, up to left 1. And if I draw my best version of a line, you can see that one of my intersections occurs here, and the other one occurs here. This intersection is at negative 2, 3, and this one is at, looks like 1.5 comma negative 4. And behold, cha-ching, cha-ching. It appears to check out just A-OK. So there you go for 15. That was the intersection of a conic and ellipse and an ellipse. Sorry, an ellipse and a line. Ellipse was the conic. Let me take a quick gander at 18. We're just going to do the setup for this one. You guys didn't have this last night, but future classes probably will. So you're welcome for my non-internet friends.
Should we write this problem down?
No, that's fine. Just follow along, absorb. So looking at this, both of these equations have both x squareds and y squareds. Both of them have the same signs for their x squareds and y squareds, Hank. So these are both ellipses. Intersections between ellipses could be 0, 1, 2, 3, or 4 intersections. So I've got all sorts of possibilities here. But what's convenient is there was no x to the first or no y to the first terms here. So what I would actually do is probably go for elimination method, where I'd eliminate either an x or a y first. Let's just say I wanted to, let's eliminate the x. Let's say I multiply this by -3.
Why?
Just I felt like it. Or I could have eliminated the y's there.
Do you get it?
Yeah. So keep tracking here. Keep tracking with me. So here we go. Multiply through 3x squared minus 3x squared is 0. Y squared and -6y squared is -5y squared. 9 and -30 is -21. You don't say. Divide both sides by -5. And I would get y squared equals positive 21/5. And what would I do to solve from here?
Plug that in.
Nope.
Oh, you have to square root it.
Root both sides, and what would I never forget? Plus or minus. So I would actually get y equals, or is approximately, technically, plus or minus, let's see, 21/5 is almost 4, and square rooting that is going to be almost 2. It's 2.0494. So what I would then do is plug in both the positive and the negative versions for one of my y's and solve for the corresponding x. But I won't take time to do that today. That's good enough as a setup. Thanks for watching, internet friends. Adios!